to the color change of the vanadium ions. First, let's talk about charging. When charging, the reaction progresses as the current flows from the positive electrode to the negative electrode. At the positive electrode, vanadium ions 4 lose electrons to become vanadium ions 5. At the negative electrode, vanadium ions 3 receive electrons to become vanadium ions 2. As this reaction progresses, the charge is completed as it is stored in the electrolyte. Next, we will explain the discharge process. During discharge, the current flows from the negative pole to the positive pole, and the reaction progresses. First, at the positive pole, the vanadium ions in the second category lose electrons and become vanadium ions in the third category. On the negative side, the vanadium ion with 5 electrons receives an electron and becomes a vanadium ion with 4 electrons. As this reaction progresses, electricity is stored in the electrolyte and discharged. A reaction occurs in which the vanadium ion with 2 electrons receives an electron and becomes a vanadium ion with 2 electrons. As this reaction progresses, electricity is stored in the electrolyte. Next, we will explain the discharge process. During discharge, the current flows from the negative pole to the positive pole, and the reaction progresses. At the negative pole, the 2 vanadium ions lose electrons and become 3 vanadium ions. At the positive pole, the reaction occurs in which the 5 vanadium ions receive electrons and become 4 lower vanadium ions. As this reaction progresses, the electricity stored in the electrolyte is extracted. This is the kind of redox flow battery that will be needed in future Earth-type societies. Even if the angle of the station collapses and the station is determined, it is a safe battery with absolutely no risk of ignition or explosion, and it boasts a super long life with a system durability of over 20 years. It is easy to respond to the storage capacity, such as being able to use it for longer if the tank capacity is increased. Possible uses include supplying power in the event of a disaster and maintaining the medical system in hospitals. In addition, the high flexibility and adjustability of the renewable energy stored in electric vehicles allows the power generated to be used for internal lighting, while any excess power is stored in the redox flow battery. On cloudy days, etc., when solar power generation alone is not enough, the redox flow battery automatically discharges the power.